Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hide bin Hussein. With the number matrix of TK23008, we present to you about the topic 7 of automotive technology, which is automotive sensor and the actuator. In modern automobile sensors and actuators play crucial roles in monitoring and controlling various aspects of the vehicle operations. Sensors are signals to read values of properties in the vehicle. An automotive sensor collects data from various electrochemical devices operating in the vehicle to measure physical or chemical variables and send it to the information of ECU, or we call it as Engine Control Unit. Common sensors in a car include the throttle position sensor, oxygen sensor, mass airflow sensors, and other than that. On the other hand, the actuators are used to control desired value of a property in a vehicle. Actuators are an essential part of electronic control system in the passenger cars and commercial vehicle. It is their job to convert the electrical signals from the control unit into an action. Most actuators are electric motors or electromagnetic valve. So, as a simple sentence, we can conclude that the sensors are the information gatherers and the actuators are the doers. So let's break to the types of the sensors. There are many types of the sensors, and the first is the position sensors. These conclude the crankshaft position sensors, camshaft position sensors, and the throttle position sensors. So let's look at the crankshaft position sensors. These sensors tells the ECU the position of the crankshaft because the position of the fixed piston is fixed in relation to the position of the crankshaft. By knowing the position of the crankshaft, the ECU also knows where the piston is inside the bore. By knowing this, it can initiate fuel injection and spark ignition events at the correct time. Crankshaft position sensors are most often either Hall effect, where it's three wires, or variable reluctance, which is two wires. Although they work slightly different, both rely on the basic principle of electromagnetism to read a trigger wheel made from a ferrous metal. This trigger wheel is going to have one or more teeth missing as a sensing teeth. Whenever the sensing teeth pass in front of the sensors, it's going to change the signal that the sensor send to the ECU. Now, the position of the missing tooth in relation to the sensor is going to be fixed to the certain position of the crankshaft. And by seeing the change in the signal, the ECU can tell exactly where the crank at the moment in time. Now, the ECU is also configured to the total number of teeth on the trigger wheel. And by knowing the total number of the teeth, measuring how often the missing tooth passes in front of the sensor, the ECU can calculate the edge speed or RPM. Every car engine has only one crankshaft, thus it is only need one crankshaft position sensor. The crankshaft position sensor, in order to read the trigger wheel, must be located very near it. The trigger wheel must be installed on something that rotates at the same speed as the crankshaft, and it's usually either the crankshaft pulley, the timing gear where the timing belt or timing chain attaches, and also the flywheel. So one of these three locations is where you're going to find your crankshaft position sensor. So what is the effects if your crankshaft position sensor fails? It will appear in a code of P0335, which you have fails and no start, you had a hard start engine. It can be start but stall soon after and have uneven acceleration. Your engine can cause also misfiring and have rough idle, which also lead to the poor mileage. Next, the camshaft position sensor. Now the camshaft position does the same thing as the crankshaft position sensor but for the camshaft. Now, in theory, the engine can run with a crank sensor alone, but adding a camshaft position sensor paints a much more complete picture for the ECU. And it is also a layer of verification for the information coming from the crankshaft position sensor. Now, a camshaft position sensor lets the ECU knows what each cylinder is doing and when it will be doing. And this is what it can be used. For example, cylinder select node control, sequential injection, and other selective system. The cam sensor works on the same principle as the crank sensor. The only difference is that it reads a much small trigger wheel with fewer teeth due to the size of the camshaft. To read the position of the camshaft, the sensor must be near to it. Usually, you're going to find this sensor somewhere on the cam cover, either at the front or at the back of the camshaft, or less of the somewhere less often along the axis of the camshaft. Failure symptoms of the camshaft position sensor are usually the same or very similar to the position sensor. If fails, it will hard to start, and if it is start, it will stall soon after. Bodoh. Next, we're going to the throttle position sensor. The throttle position sensor measures the position of the throttle plate. When you operating the throttle pedal, you are actually operating the throttle plate. They're usually at the entrance of the intake manifold. So, when you floor it, the throttle plate gets fully open, allowing the maximum air into the engine for maximum acceleration. By knowing the position of the throttle plate, the ECU can know the load placed on the engine and can thus vary injection and ignition timing accordingly. A throttle position sensor works relying on the variable resistor. A variable resistor is essentially an electrical component which changes its electrical resistance output based on its positions. It contains a movable part, and different position of this movable part will have different resistance output. In case the throttle position sensor, the throttle plate shaft is connected directly to the variable resistor. Slightly different position of the throttle plate will have different resistance output, which are then measured and converted into a useful signal for the ECU by the onboard electronics of the throttle position sensor. Now, it is what an old throttle position sensor used to work with, but today, a modern position sensor actually rely on non-contact position measurement and either use Hall effect, induction, or magnetic resistance to do the same job as variable resistor. Obviously, to measure the position of throttle plate, the throttle position sensor must be located on the throttle body itself. One of the most obvious symptoms of failed throttle position sensor is going to be unpredictable acceleration. The car is going to feel as tough and is not correctly responding to throttle pedal inputs. Also, the idle will often be effect, either is too high or it will too low, and there also might be difficulty starting the vehicle. This fails will go error code of P0122 and P2135. Next, we will be talking about the type of sensors, which are the airflow sensors. The airflow sensors have two types of sensors, which are mass airflow sensors, which are called MAF, and the vent airflow meter sensors, FAM. The MAF, mass airflow sensor, in addition to knowing the position of piston so that we can know when to eject the fuel, the ECU must also know how much the fuel to inject. And to know how much fuel to inject, it must know how much air is coming into the engine. so that it can inject a corresponding amount of fuel. And this is exactly what a mass airflow sensor does for the ECU. It tells the ECU, which is engine control unit, how much air is coming into the engine. Now, most mass sensors are either hot wire or hot film. Now they are a bit different and the hot film sensor is a bit more advanced, but they both rely on the same basic principle of the very high temperature coefficient of resistance of certain metals such as plasma or tungsten. The very high temperature coefficient of resistance of these metals means that even very minute changes in the temperature of this metal will change their resistance. So when air flow over metals, it changes their temperature. The more air flows over, the more the resistance changes, and the onboard electronic of the mass sensor measure this and then convert the signal into useful data for the ECU. You will easily find a mass right after the air cleaner housing, the air filter housing. If it's not there, it's going to be somewhere after the air filter housing, but before the throttle body. If the mass airflow sensor fails completely, the engine will not start. If it is only starting to fail or if it's a bit contaminated by dirt, then it's going to send the wrong information to the ECU. So the ECU will be injecting the wrong amount of fuel and you can expect rough running engine, a poor idle, hesitation during accelerations, and the engine stumbling, poor mileage, and other similar symptoms. For the error code, it will appear P0101 and P0102. The airflow meter or van airflow sensor meter is also known as the same thing as the MAF. It measures how much air is coming into the engine. It just does it different and it is usually present on all vehicles. The airflow meter has a flap or a vane inside it, and the incoming air pushes against this flap. The more air is coming in, the more it will push against the open the flap. Now the vane or flap is connected to, for example, a resistor, just like the throttle plate shaft of a throttle position sensor. Different vane positions are going to help it. Different resistance and all the electronics are going to measure this and convert it into a useful signal for the ECU. So the different resistance output will tell the ECU how much the vane is open and how much is air coming into the engine. Just like the mass sensor, the airflow meter is always going to be somewhere near or right after the air filter. Since it's doing pretty much the same thing as a mass airflow sensor, the failure symptoms of the airflow meter sensor are going to be similar or the same as with the mass airflow sensor, but in a different non-universal code, which have hard to start, poor mileage with poor acceleration, and have hesitating engine. Now, let's talk about the pressure sensor types. We have three types of pressure sensor, which is the manifold absolute pressure sensor, of, or we call it as MAP, and oil pressure sensor, and also fuel pressure sensor. Next, we talk about manifold absolute pressure sensor, or other name we call as MAP. Like the MAF or the FAM, the MAP sensor measures how much air is coming into the engine. But unlike the AFM or the MAF, it does not measure the incoming air mass directly. Instead, it measures pressure inside the engine's intake manifold and calculate the air mass based on that. The logic is that the more air there is in cold spills, the greater the pressure the air is going to exert onto the walls of the cold space. And this is exactly what the MAF is using. And by measuring the pressure, it can calculate how much air is coming into the MAP map. The manifold absolute pressure sensor measure intake air pressure by relying on a tiny micro silicon chip. The silicon chip consists of silicon membrane and a tiny piezoelectrical material. The piezoelectrical material reacts to the flexing of the silicon membrane under pressure by changing its electrical charge. The more the pressure there is, the more the silicon membrane flexes and the more charge changes. And the onboard electronic measure this and then convert it into a useful signal for the ECU. This manifold absolute pressure sensor can be found and located in the intake manifold. So, what happens if this sensor is failed? It will appear code of error PO106 which have problem, no start engine, have a poor mileage, poor acceleration, and also have hesitating engine. Next, the oil pressure sensor. So the older cars have the diaphragm bases, and the newer cars have the piezo-resistive pressure transducers. So what actually is the function of this sensor? The sensor obviously measures oil pressure inside the engine. It is very simple, but perhaps one of the most important and vital sensors for the engine because without enough oil pressure, the engine is going to sustain catastrophic damage very quickly. Just like many other pressure sensors on a car, the oil pressure sensor is basically a piezo-resistant pressure transducer, meaning that it works on pretty much the same basic principle as the map sensor we just covered. It's simply calibrated for the different values expected from the engine's oil pressure. Now, in some cases, the oil pressure sensors of an engine is not a sensor at all. It's just a switch and the most basic version contains a diaphragm. When it flexes, it simply causes an electric circuit and reports that there is a sufficient oil pressure. If there is not enough oil pressure, the diaphragm is not going to flex enough. It won't be able to cause an electric circuit and an oil pressure light is going to illuminate warning the driver that the engine should shut down to prevent that. The oil pressure sensors is usually located somewhere on the engine block, often near the oil filter, but it can be anywhere on the engine block where it can be tapped directly into an engine oil passage so that it can accurately read the oil pressure. So what happens if these oil pressure sensors fails? First, you will get a code of PO520 until 522. A lack of oil pressure is one of the single most dangerous situations for an engine. So, if the oil pressure sensor is malfunctioning and falsely reporting low oil pressure to the ECU, failure has no effect on how the engine runs unless oil pressure is actually low. For low oil pressure reporting can trigger a light bulb mode will refuse to start the engine. Next is the fuel pressure sensor. So the function of the fuel pressure sensor, it measures the fuel pressure. It tells the ECU in how to estimate the time to open the fuel injectors. By knowing the fuel pressure of the fuel inside the fuel rail, the ECU can know how long to open the injectors in order to ensure that the correct amount of fuel is injected into the engine. In order to measure fuel pressure right inside the fuel rail, the fuel pressure sensor is almost always located somewhere directly on the fuel rail. Usually, the first symptom of this sensor if fails is difficulty to start the engine, especially on a cool engine. Other symptoms include poor acceleration and also poor mileage. This error code will appear with the number of P0193 and also P0190. Next, we'll go to the types of temperature sensors. So in this temperature sensors, we have four types of temperature sensors. First, intake air temperature sensors, which is IAT, the coolant temperature sensors, the fuel temperature sensors, and also the oil temperature sensors. Next is the intake air temperature sensors. The IAT sensors or the intake air temperature sensors obviously measure the temperature of the intake air. It is important to do this because air density is influenced by air temperature. The hotter the air, the less dense it's going to be, and the less molecules of air are going to be in a given space. Although in theory an engine could run without an air intake temperature sensor, it is still a very good idea to have one, and the engine is going to run better with it than without it. The IAP sensors works together with the MAF, the MAP, or the AFM to give the ECU a more complete picture of the air coming into the engine, which help reduce emission and improve power and efficiency. Just like almost all the other temperature sensors in the car, the IAT sensors is a thermistor, meaning that its electrical resistance is going to change in response to the changes in its temperature. And then as usual, the resistance is measured and converted into a useful signal for the ECU. The IAT sensor is often integrated into the MAF or the FAM. If it's not there, you can usually find it somewhere in the intake, usually near the throttle body. If there is only a little bit of dirt on the IAT sensors, then malfunction symptoms are going to be very mild and very noticeable. If fault is more severe and then the engine may run rough, stumble or even stall, or it can have very mild short surges of power. Let's proceed to the coolant temperature sensor. Now, the coolant temperature sensor is very important for the ECU because it tells to the ECU how warm the engine is. This is important because a cold engine needs a different amount of fuel when compared to a hot engine. The coolant temperature sensors is also needed to trigger various actions such as, for example, starting the radiator fans or if the engine is overheating. It can tell the ECU to trigger the limp on mode or refuse to start the engine until it cools back down. Like almost all the other temperature sensors, the coolant temperature sensor must come into the direct contact with the fluid whose temperature it is trying to measure. As such, you are very often going to find a coolant temperature sensor at near the thermostat. Some cars have more than one, and you can find them anywhere on the coolant piping or whenever else coolant is passing through. A cold engine needs more fuel than a hot engine. This means that if the coolant temperature sensor is malfunctioning and telling the issue that the engine is cold even though it is hot, the issue is going to inject extra fuel, which is going to result in a rich running condition. And this means you are going to get poor mileage or even black smoke for the exhaust in severe cases. An opposite scenario is also possible, and the ECU can think that the engine is hot even though it is cold. In that case, it is going to inject too little fuel, which is going to lead to a lean running condition, and this can lead to the engine misfiring or even knocking until it's hit hard. So this failure will appear code of P0116, P0117, and also P0118. Next is the fuel temperature sensor. So fuel temperature sensor must be measured because of the fuel density. Just like the density of air, it is affected by temperature. Hot fuel is less than and burns more easily, so a bit more if must be injected to compensate for this. So its function is to improve fuel injection accuracy for stringent emission standards. The fuel temperature sensors is most often located somewhere at the fuel tank, often as part of the fuel pump assembly. As often it can be found somewhere else along the fuel line. The information is coming from the fuel temperature sensor is only used to further improve the injection accuracy in order to meet stringent emission standards. An engine can run pretty well with a faulty fuel temperature sensor, and in some cases symptoms might not be noticeable at all. If the fault is more severe or if the sensor completely fails, then the vehicle might fail an emission test or get slightly worse mileage and performance than usual. Overall, an engine can run pretty well with a faulty fuel temperature sensor. In some cases, symptoms might not be noticeable at all. Although many cars only have an oil pressure sensor and do not measure oil temperature, measuring oil temperature can be a useful additional layer of protection. If the oil overheats, this is going to negatively impact its viscosity and the oil won't be capable of doing its job, which can lead to engine failure. Note the issue by seeing the oil temperature can activate the link-off mode or refuse to start the engine before oil temperature normalizes again. In addition to relaying information to the ECU, the oil temperature sensor can also relay information to a gauge or display visible to the driver, and then the driver can take primitive action and shut the engine down. If oil temperatures get too high, in order to be able to measure the temperature of oil, the sensors must come into direct contact with the oil inside the engine. As such, it's often found on the engine block or less often on the cylinder head. In newest cars, it can be found integrated into the oil level sensor. Depending on how it's failed, a malfunctioning oil temperature sensor might take the issue think that the oil temperature are too high, even though they are not, and then the issue might incorrectly trigger a link off mode. The sensor can also malfunction in a way that it fails to report overly high oily temperature, which can result in engine damage. A faulty oil temperature sensor is very easy to spot if there is a gauge or display for it. Next, we look up at the type of the sensors, which is the air-fuel ratio, emissions, and the other types of sensors. It is include of oxygen O2 sensor, spark knock sensor, voltage sensor, and vehicle speed sensor. Next is the oxygen O2 sensor. The oxygen sensor measures the amount of oxygen present in the exhaust gas. The amount of oxygen present in the exhaust gas directly corresponds to the amount of fuel burned inside the combustion chamber. By measuring the oxygen sensor can actually tell the ECU the air-fuel ratio at which the engine is running. The air-fuel ratio, or the ratio of the air to fuel inside the combustion chamber, is absolutely critical for both engine performance and emissions, and must be constantly monitored to ensure that it is where it needs to be. We have two kinds of the oxygen sensors, narrowband and a wideband. Narrowband sensors can tell if the engine is running rich or lean, but they cannot tell exactly how rich or how lean the engine is running. On the other hand, the wideband sensors cover a much wider range of air-fuel ratios and can tell the ECU exactly how rich or lean the engine is running. Although it is small, the oxygen sensor is a pretty complicated device. It involves zirconium bulbs and various plating, and what's not explaining it, this video could make video too long or complicated. So for the purpose of this video, what I will tell you is that the amount of oxygen measured at the sensor tips correspond to a voltage produced by the sensor. So for example, 0.5 volt is going to be near the ideal F ratio, and at the other far ends of the spectrum, we can find 2 rich and 2 lean. So what the issue is going to do is increase or decrease the amount of fuel injected in order to reach again the either F fuel targeted ratio. Now, most catalytic converter equipped cars are going to have a minimum of two oxygen sensors. One is going to be before and one after the catalytic converter. The one before the catalytic converter is called the upstream oxygen sensors, and it's usually going to be right at the exhaust manifold or right behind it. And it is used to see the exact air-fuel ratio at which the engine is running. The one after the catalytic converter, that sensor is called the downstream sensor, and used to verify that the catalytic converter is properly doing its job. Failure symptoms can range from barely noticeable to very noticeable, but even if the symptoms are hard to notice, the vehicle is likely going to fail an emission test. Now, if it is noticeable, it is going to be real noticeable. The engine is going to run rough, especially on more modern cars, which rely more heavily on the oxygen sensor. More modern cars can even refuse to start the engine if the sensor has completely failed. If you know that you have a bad oxygen sensors, then it is a really good idea to replace it as soon as possible. Even the vehicle is running okay, because an overly rich running condition can lead to your catalytic converter failing for more sooner than it needs to be. If this fails, it will appear error code of P0131 and P0133. Next is the exhaust gas temperature sensor, or we call it as EGT. So as it names, it states the function, which is EGT is an exhaust gas temperature sensor. It measures the temperature of the exhaust gas. Now, an EGT is a probe that must be present directly in the exhaust stream in order to measure the temperature of the exhaust gas. By measuring the temperature of the exhaust, we can infer information about the air-fuel ratio, because changes in the air-fuel ratio are also going to be directly correlated with changes in the exhaust gas temperature. Now, an EGT probe is not often used on gasoline engine, but it can be useful to protect the turbocharger and the catalytic converter from thermal overload. Now, EGT probes are often used on turbo diesels and diesel engines to verify that the DPF, or diesel particulate filter, has reached a sufficiently high temperature for regeneration. They are also useful for the protecting the SCR or selective catalyst reduction and LNT or lean knock strap and other NOx absorbing system. Although it is considered an old tool when it comes tuning performance on racing engine, an EGT prop can still be a very useful tool that provides valuable insights into what's happening inside the engine. In order to get the most accurate reading of the exhaust gas temperatures, the EGT probes must be as close to the exhaust valve as possible. This is why we are always going to find it in the exhaust manifold, very close to the cylinder head. The other location is also going to be after the DPF or diesel particulate filter to verify if the DPF is doing its job. The exhaust gas temperature sensor are very rarely present from the factory on gasoline engines, so they really are not and very common are not any very common systems to discuss. When it's come to diesel vehicle, any EGT failure is going to cause the vehicle to go into regeneration mode very often, and regeneration mode is going to last longer than usual, and you may also get poor mileage and poor performance. Next is the nitrogen oxide sensor, or we call it as NOx sensor. So these blocks are nitrogen oxide sensor, and they measure the amount of nitrogen oxides in the exhaust gas. They usually only present on diesel vehicle and were briefly present on some certified charged gasoline engine in the past. Their main role is to verify the correct operation of the SCR or the selective catalyst reduction systems. This is an active emission system in diesel vehicle which injects ammonia or diesel emission fluids directly into the exhaust gas and this convert the nitrogen oxide into nitrogen, water, and minute amount of CO2. There are usually two of these sensors in a diesel vehicle, and one before and one after the selective catalyst reduction system. The one before measures how much nitrogen is coming in, and the other one after measures how much nitrogen oxide is coming out to make sure that the selective catalyst reduction system is doing its job. This failure of this nitrogen oxide sensor, or we call it NOx sensor, is going to trigger most modern diesel vehicle to go into limp mode home mode. You also might get an erratic idle and poor mileage with an error code of P2202, P2200, P229F62, and P229E. Next is the NOx sensor. NOx is an abnormal combustion inside the engine. If it is strong enough and if it persists long enough, it can cause catastrophic engine damage. A NOx sensor is essentially a microphone tuned to listen the specific frequency of knock inside the engine. This frequency depends on the engine, but largely it is actually depends on the bore and stroke of the engine. If the knock sensor detects knock, it's going to relay this information to the ECU, and the ECU is going to respond by either retarding ignition timing or increasing the amount of fuel injected into the engine to prevent the knock from occurring again. In order to be capable of hearing the knock resonating through the engine block, the knock sensor is always going to be on the engine block. Many engines with 6 or more cylinders have 2 or even more NOx sensors in some cases. In many cases, a NOx sensor failure will have zero effect on the way the engine is running. you might get a check engine light, but the engine will run completely normal. Now, the scenario is a bit different on the modern cars, whose issue once it detects no sensor failure is going to often trigger limp home mode until the knock sensor is replaced. This error code of this knock sensor failure will get P0325. Next is the voltage sensor. Voltage sensor in cars play critical role in monitoring electrical system health, ensuring optimal performance and safety. The sensor measures the voltage level in the vehicle battery and electrical circuits, providing real-time data to the engine control unit, which we call as ECU, and other electronic control module. The function of the voltage sensor is to charge system control, battery monitoring, and fault detection. So what happens if this voltage sensor fails? It can lead to electrical system malfunctions, including erratic engine behavior, difficult start to engine, dimming lights, and potential damage to sensitive electronic components. Prompt detection and replacement of a faulty voltage sensor are essential to prevent further electrical system complication and maintain the vehicle reliability and functionality. This also will lead to engine performance issues and battery problems. Next, we will talking about the vehicle speed sensor. So, this vehicle speed sensor measures the speeds of gear in transmission system. It will tell the ECU for the ignition timing air-fuel ratio. Vehicle speed sensors in car are integrally components that monitor the speed of the vehicle by detecting the rotation of specific components, such as the wheel or transmission output shaft. They provide crucial data to the engine control unit, which is called as ECU, and other control modules for various functions, including regulating fuel injection, transmission mission shifting, and anti-lock braking system, what we call as the ABS. So, what happens if these vehicle speed sensors failure? If a vehicle speed sensor fails, it can lead to inaccurate speedometer reading, transmission shifting issues, and ABS malfunction, and erratic behavior of cruise control system. Timely detection and replacement of faulty vehicle speed sensors are essential to ensure safe and efficient vehicle operation. As an end of the word, we can conclude that the sensors and actuators are essential components in vehicles, collectively forming the backbone of modern automotive technology. Sensors detect various parameters such as speed, temperatures, pressure, and position, providing vital data to the vehicle control system, which we call it as ECU. This information enables precise monitoring and control of engine performance, emission, fuel efficiency, and safety features like the ABS and traction control. Actuators, on the other hand, respond to signal from the control system to perform specific action, such as adjusting fuel flow, changing Q ratios, or activating safety system. Together, sensors and actuators ensure optimal vehicle operation, enhancing performance, reliability, and safety on the road.